So the second question, you can later read it in detail, but very quickly, this is the story. Consider the following strategic situation concerning the owner of a firm, the manager of the firm. So MO refers to owner and a manager and owner, and a potential worker. So W is these are the names of my players, okay? And the potential worker. So there are 3 players. Good. The owner first decides whether to hire the worker or refuse to hire the worker, or to let the manager make the decision. All right. Well, according to this definition, the owner moves first, and he has or she has, I'm going to refer to him as he, has 3 actions. All right. He can hire the worker. He can don't hire the worker, and then he can basically delegate the decision to the manager. All right? Good. If the owner lets the manager make the decision, I mean we're here, then the manager must choose between hiring the worker or not hiring the worker. So it basically says, if the owner delegates, the manager moves second, and he has 2 sort of options: hire the worker or don't hire. All right? Good. If the worker is hired, then he or she chooses between working diligently and shirking. All right. So the worker also has 2 actions, like manager. And these actions are working diligently or shirking. Shirking, I don't know if you know, but basically, pretend to be working, but actually not working. So assume that the worker does not know whether he or she was hired by the manager or the owner when he or she makes his decision. All right, so these are very important pieces of information. What does it say? It says the following. The worker obviously observes whether he's hired or not, right? So therefore, the hire decision, don't hire decision, he can distinguish these 2, and this don't hire and these hires. But the thing is, whenever he is hired, he is unsure whether it's coming from the owner himself directly or indirectly, and from the manager. So what does that mean? That means I need to put those 2 decision notes into same information set. And this is where the worker moves. And as I sort of mentioned in my videos, some textbooks just puts dots. Some puts sort of circle between. Either way is okay. Or if you like, you can do both. We usually don't do both. So either way is okay. But that means the player here cannot observe whether this hire decision is coming from the owner or coming from the manager. All right, so that's how we model this strategic environment, this information structure. Okay, I continue. Oh, remember the worker has 2 options. Working diligently, work diligently, or shirk. And obviously whether he or she was hired from the owner or through the manager, doesn't matter. He still has 2 options: work diligently and shirk. All right. Well, what about he's not hired? I mean, is this the end of the game? Well, probably the question is going to tell us something about it. All right, so let me continue reading. If the worker is not hired, all right, so it's talking about this note and this note, because it doesn't say anything about whether he's not hired through the owner or manager. If it is not hired, all right, it could be either one of those. Then all 3 players get a payoff of 0. All right, I'm going to put this vector 0, 0, 0. So 0, I'm sorry, it's not O. And same here, 0, 0, 0. So there are going to be 3 payoffs, because those payoffs are going to be coming from, these payoffs are for the owner, the first player. the second player, the manager, and the last player, the worker. All right. Usually we keep this order the same throughout all the payoffs. That's very important. I mean, if you put owner's payoff first here, and then here, if you put, I mean, here they're same, but if you put the owner's payoff the second or the third somewhere else, that's a problem. You shouldn't do that, all right? You should stick to the order throughout this game. What else?
So, Professor, info set like where we do not know like blindly what is other player doing. Yes.
So here exactly the worker is blindfolded. He can't see whether he's hired from the through the manager or the worker. But everything else, meaning once he's not hired, he can observe that because that's the end of the game. Clear?
Yes. Thank you.
All right. If the worker is hired and shirks, all right. If the worker is hired and shirks, so it's talking about these notes. I don't know if these are decision notes, meaning whether the game will continue or whether this is the final note. We'll see that. We'll figure this out now. If the worker is hired and shirks, then the owner and manager each get a payoff of -1, whereas the worker gets 1. So the game is going to be over. -1 for both owner and manager, and +1 for the worker. Same here. Good. What else? If the worker is hired by the owner and works diligently, okay, hired by the owner and works diligently, it means now we are in this note. Then the owner gets a payoff of 1 +1. The manager gets 0, the owner gets the whole credit, in a sense, and the worker gets 0. Well, you may say why he's getting 0 payoff. I mean, at this point, please do not really care much about the payoffs, but one way to interpret this as working diligently is costly because you have to put a lot of effort. Shirking is always, thinking of this like a teamwork. So sort of doing your problem set with a group. So you can shirk, meaning you can let all your group mates work hard and, finish the problem set and sort of submit it for you. And so you're going to get +1, obviously, without any sort of effort. But alternatively, you can also put effort. And so therefore the return, the net return is 0. All right. So that's the idea. Shirking is always a good thing, usually, unfortunately. If the worker is hired by the manager and works diligently, so it means we're here, and this is basically the final and the last remaining node that we didn't put any payoff. Then the owner gets 0, the manager gets +1, and the worker gets +1. Okay, I don't know why. All right. So represent this game in the expensive form, draw the game tree. That's it. This is the game tree of this strategic interaction. Any question, guys? Okay, so what I would like to do next is I'm going to write the strategies of each player, right? There are 3 players. I'm going to denote those strategies as the owner's strategy set, the manager's strategy set, and then finally the worker's strategy set. Okay? It's always easier to put sort of short letters instead of hire, delegate, don't hire, all right? So this is exactly what I'm gonna do. So instead of hire, I'm gonna put it A. Don't hire, it's gonna be B. Delegate is going to be C. Okay? Because again, it's easier to write A, B, C instead of hire, don't hire, etc. So M, it's going to be hire, don't hire. Well, should I put A here? It really doesn't matter. Okay? If you like, you put A here and B here as well. If you like, you put something else. It's totally up to you guys. Why is that? Well, because these are actions of another player. This is why it doesn't matter, okay? So I'm going to call them therefore, because these actions belong to a different player, I'm going to call them different letters, DE, etc. And then finally, work diligently, shirk. Here, again, because this is a different player, I can put A, B, or C, D, E, F, whatever. I mean, any letter is fine. But because it's a different player, I'm going to put different letters. However, let's call it, I don't know, XY. Putting here XY and putting here ZW. Well, there's nothing wrong with this, okay? Okay, I'm sorry, I take it this back. I mean, when I say there's nothing wrong with this, it's not 100% true. So the thing is, what matters is how you write the strategies. That is what matters. So whether you put ZW here or XY here, again, I mean, as long as you write the strategies correctly, I would be perfectly fine with this. But the thing is, someone who puts different letters here will probably also write the strategies wrong, all right? I mean, there is like 95% sort of correlation. I know that, statistically speaking. Why is that? Well, here, don't forget, whenever we have two decision nodes in the same information set, that means the player, which is worker here, cannot distinguish this decision node, the one on the left and the one on the right. So that means when he is called upon to choose an action, if we tell him that his available actions are XY versus ZW, that actually implicitly, not explicitly maybe, but implicitly means the guy, the worker, can actually distinguish these decision nodes because these are two different action sets. All right? So in order to be consistent with our story, being the worker cannot distinguish these two decision nodes, and therefore he shouldn't be able to distinguish the actions available in these two decision nodes. So we should call them also X and Y. That's very important. Any question? All right. So then I just mapped the strategy. So remember the definition of strategy. It's awkward in a sense, all right? Get used to it as early as you can because trust me, we will keep using this definition, this idea of strategy throughout this course. I mean, it's not going to change. It's going to be fixed, all right? And try to make sense out of it. If you can't, please, I mean, email me, ask your questions. It doesn't have to be today, but later. So this description of strategy is very important, trust me. So what is the description of strategy? Simple. Strategy is actually a function that maps each decision node or information set means the same thing, all right? So this is an information set, but there are two decision nodes, so we basically do not distinguish them whenever they're in the same info set. So this is a decision node, but this is also an information set, in fact, right? This information set has only one decision node in it. So instead of calling them decision nodes and or info set, let's just call them info sets. So therefore, strategy is a function again, and that function maps each info set of a player to an action that is available at that info set. Okay? So how many info set player O has in this game? Just one, because he's moving just once. So therefore, how many available actions does he have? Available info set, he has one. Available actions, he has three. So therefore, he has 3 to the power 1 strategies. Strategies, oh boy. Can we generalize this? I mean, if we call this set, I don't want to use the same letters, D, and if I call this set F, can I say the guy has always F to the power D strategies? Oh yes, okay, that's kind of the rule. So his strategies are therefore A, B, and C. Question? All right. What about the manager? Manager has one info set in this entire game because he's moving just once. And there are two available actions, so therefore he must have two strategies, and they are D and E. And what about the worker? Well, the worker has one info set. He has two decision nodes, but remember, he can't distinguish these two decision nodes. So he has one info set, and therefore, in this info set, there are two available actions. So 2 to the power 1, he has two available strategies, which are X and Y. So that's it. These are the strategies. Question is, how can I transform this game to a normal form representation or normal form representation or strategic form? The normal form representation or strategic form representation of a game is basically representing this game tree by taking the strategies into account without looking at the sort of the timing of the game, just the strategies. All right. I did not make any example where there are 3 players in the videos, but here I have, so in the 2-player environment, it's simple, right? It's a matrix. The role player is the player 1 or the first player, and the column player is player 2, which is the manager. But what about the worker? He's the third player. How am I going to sort of put it? I mean, the matrix has two parts, right? The row and the column. So how am I going to represent W? Well, simple. If I have 3 players, then I represent the matrix as the third player. All right. So he chooses the matrix rather than rows and columns. But if I have 4 players, there's no way you can represent it, you know, physically at least, in a normal form representation. All right. Again, it's like you cannot draw the normal form when there are more than 3 players, like 4 or 5. Obviously, in an abstract way, you can construct the normal form game as long as there are more than, more than or equal to 2 players, meaning you can always construct it. But drawing it on a board is impossible if we have more than 3 players. Strategy of a player does not depend on strategies of others. Yes, so this is very important. Strategies are independent of what the others do, all right? So that's very, very important. My strategy will never depend on what you do, all right? Meaning, when I describe my strategy, it only depends on the number of information sets I have. Of course, those information sets, whether we are going to reach to those information sets or not, these obviously depend on what you do. But playing the game, or sort of the path of the play, is something which we haven't defined it yet formally, but strategy is something else. So this is exactly what I mean by the details are very important. Strategy, again, is a function that maps each player's information sets into an action that is available at that info set. And so by definition, if you look at it, the strategy has nothing to do with the other guy's strategies. All right, so that's very important. So for that reason, does it matter whether I construct the manager's strategy first and then the worker and then the owner? It makes no difference. All right. So these are the strategies. Now I'm going to represent them in a normal form. I need some space. So I'm sorry for cleaning up this mess, but I need the space. So I'm going to write them here. So remember, I'm going to put owner, because he's the first player, as a row player. And he has 3 strategies. So there's going to be 3 rows. And I'm going to put the manager as a column player, and he has 2 strategies. Therefore, there are going to be 2 columns. But remember, the worker is the matrix player. And so because he has 2 strategies, that means there must exist 2 metrics to represent this game's normal form. Obviously, the second matrix will have similar three rows, two columns, because the first and the second player's strategies are 3 and 2, respectively. So, this is the manager, remember? Manager. And the manager's strategies are D and E. D and E. And then the role player is the owner. So this is the owner. And he has 3 strategies, A, B, C, A, B, C. And so this entire matrix happens or occurs when the worker chooses X, and this occurs when the worker plays Y. So now I'm going to put the payoffs. What is the payoff of those 3 players when the owner plays A, the manager plays D, and the worker plays X? So owner plays A, all right. The manager plays D. Well, you know what? The manager's action will not be called upon. So D or E doesn't matter, because whenever the owner chooses A, the game is going to go through the sort of third stage where the worker plays. So therefore, the manager's action is irrelevant. All right? So, however, the worker's action is relevant. If he plays X, he's going to get +1. The payoffs will be 1, 0, 0. So therefore, here it's 1, 0, 0. Here it's also 1, 0, 0. Why is that? Because remember, whether the manager chooses D or plays D or E, who cares? The game will never go to this side of the game. All right? For that reason, it's going to be 1, 0, 0, and same here. However, if the manager decides to play Y, given that the owner decided to play A, the payoffs will be -1, -1, +1. So these are going to be the payoffs. All right. When the owner plays B, I'm now filling up the second row. Well, the game will be over for all of them, and everybody will get 0, regardless of what strategy they pick, because their strategies are irrelevant. Okay? Now, C. What if he picks C? Well, if he picks C, the manager's decision is important, because if he picks E, the game will be over. Again, irrelevant of whether the worker chooses X or Y. So I'm going to put 0, 0, 0 on. And now I have C again by the owner. And then the manager is choosing D. And then finally the worker choosing X. It's 0, +1, +1. And if he chooses Y, it's going to be -1, -1, +1. And so this is what the normal form representation of this game will look like.